NENOMATICA, where mathematics meets YouTube excellence. Exponential equations. Welcome to this mathematics lecture on exponential equations. Today, we'll solve an exponential equation step by step. Our approach will involve converting different bases to the same base, and then applying the property that if we have the same base on both sides of an equation, their exponents must be equal. Let's look at this example. We need to solve the exponential equation. 0.008 raised to the power of x minus 2 equals 25 raised to the power of 3 plus x. Our first step is to rewrite 0.008 as a fraction. 0.008 equals 8 divided by 1,000. We'll write this as 8 over 1,000, keeping the same exponent x minus 2. On the right side, we note that 25 is 5 squared, so we can rewrite 25 raised to the power of 3 plus x as 5 squared, all raised to the power of 3 plus x. Next, we simplify the fraction 8 over 1,000. 1,000 is 10 to the power of 3, and 8 is 2 cubed. So 8 over 1,000 equals 1 over 125, which we'll write as 1 over 125 to the power of x minus 2. Now, we need to express both sides in terms of the same base. Since 125 is 5 cubed, we can write 1 over 125 as 5 to the power of negative 3. So our left side becomes 5 to the power of negative 3, all raised to the power of x minus 2. We can now apply the rule that says when we have a power raised to another power, we multiply the exponents. So the left side becomes 5 to the power of negative 3 times the quantity x minus 2. This gives us 5 to the power of negative 3x plus 6. Since we now have the same base, 5, on both sides of the equation, the exponents must be equal. So we can write negative 3x plus 6 equals 6 plus 2x. Now we solve for x. First, let's move all terms with x to the left side and all constants to the right side. We subtract 2x from both sides and subtract 6 from both sides. This gives us negative 3x minus 2x equals 6 minus 6. Combining like terms, we get negative 5x equals 0. Finally, dividing both sides by negative 5, we get our answer x equals 0. Let's look at our example problem. Solve the exponential equation 6 raised to the power of x minus 1 plus 6 raised to the power of x equals 252. In our first step, we'll rewrite 6 to the power of x minus 1 as a product. Notice that 6 to the power of x minus 1 can be written as 6 to the power of x times 6 to the power of negative 1. Now, we know that 6 to the power of negative 1 is the same as 1 over 6, so we substitute that in. Looking at our equation, we can see that we have 6 to the power of x multiplied by 1 over 6 plus 6 to the power of x again. We can factor out 6 to the power of x from both terms. Let's simplify what's inside the parentheses. We have 1 over 6 plus 1, which equals 1 over 6 plus 6 over 6, which gives us 7 over 6. Now we have 6 to the power of x times 7 over 6 equals 252. Let's divide both sides by 7 to isolate 6 to the power of x times 6 to the power of negative 1. After dividing, we get 6 to the power of x minus 1 equals 36. Now, we need to determine what power of 6 gives us 36. Since 36 equals 6 squared, we can write 6 to the power of x minus 1 equals 6 squared. When two exponential expressions with the same base are equal, their exponents must also be equal. So x minus 1 equals 2. Solving for x, we add 1 to both sides and get x equals 3. So our final answer is x equals 3. We have the fraction 3/4 raised to the power of x minus 2 multiplied by the fraction 9/16 raised to the power of x minus 1 equals the fraction 6/8 squared. To solve this equation, we'll first simplify the terms and convert them to a common base. Let's start by rewriting 9/16 as a power of 3/4. 9/16 can be written as 3 squared over 4 squared. Now we can rewrite this as 3/4 squared. Since 3/4 squared is raised to the power of x minus 1, we get 3/4 to the power of 2x minus 2. Next, we combine the exponents. We have 3/4 to the power of x minus 2 multiplied by 3/4 to the power of 2x minus 2. Using the law of exponents, when we multiply same bases with different exponents, we add the exponents. So we get 3/4 to the power of 3x minus 4. Looking at the right side, we have 6/8, which simplifies to 3/4 squared. Since both sides now have the same base, 3/4, the exponents must be equal. 3x minus 4 equals 2. Adding 4 to both sides, we get 3x equals 6. Finally, dividing by 3, we find x equals 2. This is our answer. Let's start by looking at our problem. 0.25 raised to the power of 3x minus 3 equals 16 raised to the power of x minus 1. To solve this equation, we'll need to convert both sides to the same base. Let's start by rewriting 0.25 as a fraction. 0.25 equals 25 over 100. Next, let's simplify the fraction 25 over 100. This equals 1 over 4. We can rewrite 1 over 4 as 2 raised to the power of negative 2. This will help us since we're working with exponential equations. Now, we can apply the power rule for exponents. When we raise a power to another power, we multiply the exponents. So 2 to the negative 2, all raised to the power of 3x minus 3, becomes 2 to the power of negative 2 times 3x minus 3, which equals 2 to the power of negative 6x plus 6. Since both sides now have the same base, 2, we can set the exponents equal to each other. So negative 6x plus 6 equals 4x minus 4. Let's rearrange this equation to solve for x. We'll move all terms with x to the left side and all constants to the right side. Subtracting 4x from both sides gives us negative 6x minus 4x equals negative 4 minus 6. Let's combine like terms. Negative 6x minus 4x equals negative 10x. And negative 4 minus 6 equals negative 10. Finally, we can solve for x by dividing both sides by negative 10. So x equals 1, which is our answer. Let's verify our answer by substituting x equals 1 back into the original equation. For the left side, we get 0.25 raised to the power of 3 times 1 minus 3, which is 0.25 to the power of 0, which equals 1. For the right side, we get 16 raised to the power of 1 minus 1, which is 16 to the power of 0, which also equals 1. Since both sides equal 1, our answer x equals 1 is correct. Let's solve this exponential equation. We have 27 to the x power times 9 to the power of x minus 2 divided by 1/3 to the power of 1 minus x times 6 to the x power equals 2 to the power of negative x. The key to solving this type of exponential equation is to express all terms with the same base. Let's start by rewriting each expression in terms of its prime factors. We know that 27 equals 3 cubed and 9 equals 3 squared. Also, 1/3 equals 3 to the negative 1, and 6 equals 2 times 3. Now we can use the property that says when we raise a power to another power, we multiply the exponents. So 3 cubed to the power of x becomes 3 to the 3x power. Similarly, 3 squared to the power of x minus 2 becomes 3 to the power of 2x minus 4. For the denominator, 3 to the negative 1 to the power of 1 minus x becomes 3 to the power of negative 1 plus x, and 2 times 3 to the power of x becomes 2 to the x power times 3 to the x power. To simplify further, let's multiply both sides of the equation by the denominator to eliminate the fraction. This gives us 3 to the power of 3x times 3 to the power of 2x minus 4 equals 3 to the power of negative 1 plus x times 2 to the x power times 3 to the x power times 2 to the negative x power. Let me write it more clearly. We have 3 to the power of negative 1 plus x, which is the same as 3 to the power of x minus 1. So our equation becomes 3 to the power of 3x times 3 to the power of 2x minus 4 equals 3 to the power of x minus 1 times 2 to the x power times 3 to the x power times 2 to the negative x power. Now, let's combine the terms with the same base on the left side of the equation. We know that when multiplying with the same base, we add the exponents. So 3 to the power of 3x times 3 to the power of 2x minus 4 becomes 3 to the power of 3x plus 2x minus 4, which is 3 to the power of 5x minus 4. Let's also rearrange the right side to group similar bases together. We'll group the powers of 3 together and the powers of 2 together. This gives us 3 to the power of 5x minus 4 equals 3 to the power of x minus 1 times 3 to the power of x times 2 to the power of x times 2 to the power of negative x. Now let's simplify the right side by combining like terms. 3 to the power of x minus 1 times 3 to the power of x becomes 3 to the power of 2x minus 1. And 2 to the power of x times 2 to the power of negative x becomes 2 to the power of x minus x, which is just 2 to the power of 0, or simply 1. Since 2 to the power of 0 equals 1, we can simplify our equation to 3 to the power of 5x minus 4 equals 3 to the power of 2x minus 1. When we have equal powers with the same base, the exponents must be equal. So we can say 5x minus 4 equals 2x minus 1. Now we can solve this linear equation. First, let's move all terms with x to the left side. We subtract 2x from both sides, getting 5x minus 2x equals negative 1 plus 4. Simplifying, we get 3x equals 3. In this video, we will solve an exponential equation using properties of exponents and logarithms. Let's start by examining the problem. Let's simplify this expression by rewriting it in terms of the bases 2 and 5. First, notice that 8 to the power of 1 minus x can be rewritten as 2 cubed to the power of 1 minus x, and 1/2 to the power of 3x can be rewritten as 2 to the power of negative 1, all to the power of 3x. Now, let's apply the exponent properties. First, when we have a parenthesized expression raised to a power, we distribute the exponent to each term inside. For the expression 2 times 5 to the negative 1, all raised to x minus 1, we get 2 to the power of x minus 1 times 5 to the power of negative 1 times x minus 1. Similarly, for the expression 2 cubed to the power of 1 minus x, we get 2 to the power of 3 times 1 minus x, which simplifies to 2 to the power of 3 minus 3x. And when we have 2 to the negative 1, all to the power of 3x, this becomes 2 to the power of negative 3x. Let's continue simplifying our exponents. The expression 5 to the power of negative x plus 1 simplifies to 5 to the power of 1 minus x. Now, let's combine the terms with the same base. In the numerator, we have 2 to the power of x minus 1 times 2 to the power of 3 minus 3x. When we multiply terms with the same base, we add the exponents. So this simplifies to 2 to the power of x minus 1 plus 3 minus 3x, which equals 2 to the power of 2 minus 2x. Let's make our right-hand side more useful. We know that 10 equals 2 times 5, so we'll rewrite the right side. Now, let's multiply both sides of the equation by the denominator to eliminate the fraction. This gives us 2 to the power of negative 2x plus 2 times 5 to the power of 1 minus x equals 5 to the power of negative x times 2 to the power of negative 3x times 2 times 5. Let's simplify the right side. 5 to the power of negative x times 5 equals 5 to the power of negative x plus 1. Similarly, 2 to the power of negative 3x times 2 equals 2 to the power of negative 3x plus 1. Now, for this equation to be true, the exponents of each base must be equal on both sides. For the base 2, we have negative 2x plus 2 on the left side and negative 3x plus 1 on the right side. So we get the equation, negative 2x plus 2 equals negative 3x plus 1. Let's solve this equation for x. First, let's add 3x to both sides. Simplifying, we get x equals negative 1. Let's look at an example of an exponential equation where we need to find the value of x. First, let's simplify the numerator. We have 4 terms of 8 to the power of x, which we can write as 8 to the power of x times open parenthesis, 1 plus 1 plus 1 plus 1 close parenthesis. 1 plus 1 plus 1 plus 1 equals 4. So we have 8 to the power of x times 4 in the numerator. Next, we'll convert 0.0625 to a fraction. It's equal to 625 divided by 10,000. Now, we can express 8 as 2 to the power of 3. And 0.0625 can be rewritten as 1/16, which is 1 over 16. 1 over 16 can be written as 2 to the power of negative 4. Using the exponent rule, where a to the power of b, all to the power of c, equals a to the power of b times c, we can simplify the denominator to 2 to the power of negative 4 times x minus 1. Now, we can use the quotient rule for exponents. For the same base, we subtract the exponents when dividing. This gives us 2 to the power of 3x plus 2 minus the quantity negative 4x minus 4. When we subtract a negative number, it's the same as adding the positive number. So we get 2 to the power of 3x plus 2 plus 4x minus 1. Expanding the expression, we get 2 to the power of 3x plus 2 plus 4x minus 4. Combining like terms in the exponent, 3x plus 4x equals 7x, and 2 minus 4 equals negative 2. So we have 2 to the power of 7x minus 2. Now, we express 32 as a power of 2. 32 equals 2 to the power of 5. Since the bases are the same, we can equate the exponents. This gives us 7x minus 2 equals 5. Adding 2 to both sides, we get 7x equals 7. Finally, dividing both sides by 7, we get x equals 1. This is our final answer. We can verify our answer by substituting x equals 1 back into the original equation. When we do so, we'll get 32 on both sides, confirming our solution is correct. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.